All right, good morning, everybody. We'd like to thank you all for coming out. We are We Assist. We're a group of students from the University of Delaware, and over the last few months, we've been working on hacking and modifying the Wiimotes and the Wii Fit boards to use them to help people with disabilities. Basically, our plan is to provide people with disabilities more interface options with Windows operating system. There might be future plans of porting into other operating systems, but for now we're just coding it for Windows. Basically what we're doing is we have infrared head tracking, so it tracks the movement of a person's head, and then we also have weight shift tracking to add to, like with the Wii Fit board, a little bit more mobility. We chose the Wii platform mostly because it's inexpensive. It's only about $40 per controller, and for that $40 you get a great infrared tracking camera. It tracks up to 4 different sources, and right now we're only using one source for head tracking, but in the future, if we plan on doing gesture recognition or maybe even like sign recognition with the Wiimote, it would give us more options for more sources. Also, the Wiimote has Bluetooth capabilities, and so does the Wii Fit board, and this provides a really easy connection with the Wii controllers and the Wii Fit board. So we can get that information coming straight to our computer, and then there's another library that we're using, WiiUse, which takes all that Bluetooth information, all those hex values, and then converts it into functions which we can easily read and communicate with. At this point, I'm going to pass this on to my friend Cuddles over here, who's going to talk to you a little bit about the hardware aspect of the Wiimote.
All right, so the Wiimote, everyone's seen it. Most of you guys have probably even used it. And basically, it's the controller for the Nintendo's Wii, which is the current system they have out now. And what we're working with primarily is the infrared camera in the front. And that camera detects infrared light from the sensor bar. And the sensor bar doesn't even have any sensors in it at all. It's just 2 clusters of infrared lights on both sides. And both sides have 5 infrared lights each. So to the camera, it's just 2 infrared blobs on each side of the sensor bar. And with that, it allows it to triangulate your position to tell where you are in relation to the screen. And it actually tracks up to 4 sources. So you can actually have 2 sensor bars, and it will detect all 4 blobs of infrared. Now, for the hardware, here's actual pictures of the chip inside the Wii remote, and here are the buttons. This is the adapter where you connect the nunchuck and the Guitar Hero controller, Bluetooth, and the infrared camera, which is what we're primarily working with. Now, the infrared camera supports a resolution of 1024 by 768 pixels, which is pretty good compared to most webcams you can find out there, that are for $40 that only produce about 640 by 480 pixels. So not only are you getting a good controller, but you're also getting a pretty good infrared micro camera. And the Bluetooth chip is a Broadcom 2042 chip, and it's not 100% compatible with HID. Now what HID is, it's a standard for Bluetooth, so basically it's made to connect to the Wii, right? So you can connect it to pretty much any infrared Bluetooth receiver, but it won't work. It'll work, but you'll get like these weird errors or unforeseen errors. You'll be able to work through them, but you'll get like finicky controls. So we had to work with that as well. And here are our glasses, so we made that out of just basic goggles, and we constructed a circuit for infrared sensors or transmitters, and they provide a 180-degree angle of infrared, so you can turn your head a little bit and the Wii remote will still detect you. And it's pretty energy efficient, only 1.5 volts and 50 milliamps. And here's the actual circuit. You have the 1.5 volt battery in series with 2 infrared diodes in parallel to each other, so they both get the same amount of voltage, and then the resistor in series with all of it, giving them the 50 milliamp current needed. And then here's our little lab setup. It's pretty much exactly what you see here, and it's pretty ghetto, but it gets the job done. And now I'm going to pass it back on to Robert, who's going to talk about the software end of our project.
All right, so here's a little bit about the software. As I mentioned earlier, we're using the WeUse library, and that is coded for the C programming language. Basically, it's a single-threaded, non-blocking library, and it's pretty simply coded, like I stated before. Most functions are self-explanatory. It's like set LED to turn an LED off, like set it to 1 and stuff like that. So it's mostly self-explanatory. And if you do have any questions about it, there's the website we got it from, weuse.net, has tremendous documentation on it. And it's all really basic to understand. I mean, we understand it, and we didn't really know anything much about the Wiimote coming into this. So after we got that, we decided that, okay, so we need to have C programming for our Wiimotes and C programming for the Wii Fit board. But how are we going to have them run at the same time? And then our idea for that, after much thinking, was how about we run multi-threads? So right now we have one main program that creates, which is written in C++, that creates two sub-threads, or two sub-threads, which run the Wiimote and the Wii Fit board to get the information and then relay it back to our C++ program. The reason we have a main C++ program is so that we can access other code, such as gesture recognition code that's being worked on at our school. And since that's code in C++, we need to have another code that can communicate with it easily. So one of the main features of our product is the head tracking aspect. And what it is like we have an infrared source, like Larry talked about, mounted on a pair of safety glasses, which the user puts on his or her head. Now the two Wiimotes, you have a Wiimote position to your left and your right, and they pick up your positioning on an XY coordinate, and then through a little bit of geometry convert it to three-dimensional positioning with your X, Y, and Z. We use the X and the Y coordinates right now just for mouse movement and positioning. But our ideas for the Z coordinates might be when a user leans in close to the computer, maybe magnify the screen or make the mouse disappear. So if you're reading something and trying to lean in close, you won't have a mouse in your way. At this time, I'm going to demonstrate a little bit about the three-dimensional positioning and show you a little demo. All right, so this is my main screen. Hold on, Josh, I gotta see screen. All right, so this demo is basically, we made something simple, and it creates like, just a couple images. It's a rocket ship in space, and it'll show you how we can move it left and right, up and down, and it'll also demonstrate the Z-axis by getting bigger and smaller. All right, first thing I need to do is tell the program what the distance is between our Wiimotes. Currently, we have them at 36 inches apart. It's whatever the user decides, but we found that 36 creates a decent viewable range from both Wiimotes. And then I also have to tell which Wiimote is to the left and which Wiimote is to the right. So first off, I'll say 3, because we have Wiimote 3 to the right, and we do that by lighting up the LEDs to tell which Wiimote's which. And then Wiimote 2 is to the left. The reason it says there's 3 different sources is because we also have the Wii Fit board connected, which would act as Wiimote 1. Now that everything's connected and ready to go, I put on my glasses, and very fashionable, as grungy states. But as soon as I push the up button, that'll trigger the infrared detection to start. Or it should.
Yeah, there it is.
It's on? Alright, you gotta tell me what I'm looking. Is it on?
Yeah, it's on.
Alright. So I can't, I don't have, it's presentation mode, so I can't really see the screen. So what I'm going to do is I'm going to move left and right. It should be moving left and right. I hope so.
Yeah, you're good.
It's actually moving in circles.
You're good.
Wait, I'm not done, guys. All right, so I'm moving up and down, and it should be moving up and down, I hope. Bear with me if it's not.
You're good. You're good.
All right, and then lastly, I try to zoom in and out. Is it getting bigger and smaller? All right, cool. All right, so that's a three-dimensional positioning. Sorry about that. It's more convenient when you're doing it on the screen in front of you, so. All right, I'll just close out of that. You guys can connect back to the computer. Wait. All right, you can take it out.
With the Mac, you can see it on the screen at the same time that it's up there.
Ouch.
This computer's kind of weird. I don't want to know it.
Where's it at?
Oh.
Give it a second.
What were you saying about your Mac?
No. There it is. Now we're good. Now we're good.
All right, we're all good. All systems go. Okay, so back to the presentation. Hope you guys enjoyed that. But so how does it work? I'm guessing that's probably what's all in your mind now, is how exactly are we doing it? And what we're doing is we have, as you see up here, we have our screen, and then we have a Wiimote to the left, Wiimote to the right. And they're both pointed at about 22.5 degrees out, or I guess, towards me. Sorry about that. All right, they're both pointed about 22.5 degrees towards me and up vertically. So that kind of creates more of like a background. Let's see if I can use this. It creates like this background at 0 degrees right here. And that also works for the Y direction and the Z direction. So saying that all the positioning starts there and then goes off. As far as finding the angles, since there's a resolution, since we found out the resolution is 1024 by 768, well, we were thinking, well, if the X is going, if your X coordinate is going to go from 0 to 1024, why not scale that down to 0 to 45? And when you do that, then you have a 0 to 45 degree angle, which the Wiimote is set up to project. So we did that for both the X and the Y to get our angles vertically and horizontally. After we got the angles, it was just a little bit of geometry from there. We created this formula, or derived this formula. And first we split up into two triangles, and we first found the X direction of this triangle right here. And then from there we found out the other X direction, combined them both, and you get your X coordinates, which is it's based off the distance from your left Wiimote. With one of our squares, then we were able to derive what the Z and the Y coordinates were with a little bit more geometry using the tangent function. Since we had the adjacent side, why not use the tangent function to get the opposite side for both the X and for both the Z and the Y? And as I stated before, they're the distance from this little 0 degree mark right here and up. But right now, as you see, we also have a displacement of about 14 inches, and that's just to say we don't want the user to have his head laying on the table when he has to use the Wiimote. So you got to bring him up a bit so that he or she can comfortably use it. All right, at this point, I'm going to do another demonstration about the mouse control.
1 sec. Mic seems to have died.
Oh, no, it's good.
Okay, never mind.
All right, it's good. Sorry about that. Okay, again, bear with me because I don't have the screen in front of me, but I'm going to try to demonstrate the movement of a mouse with the X and the Y coordinates. What? It's going to be hard. All right, again, I got to say the distance. It's 36 inches. And then we have Wiimote 3 to the right.
Remember, folks, he's doing this blind. Ready for the flip.
Yeah, it's like I'm from the circus. Blindfolded. All right, and I got hit up to activate the control. Is it working at all? Yeah. Wait, where is it?
Yeah, well.
Is it moving around?
That did not seem to.
Is it moving around?
No. You're just going up and down. Why?
That was a scroll wheel function.
All right, how are we doing now? Oh. All right, now how are we doing?
There you go.
All right, there we go. So I'm moving the mouse around, or I hope I am. I hope I'm moving the mouse around. I can't see where the box is.
All right.
Move my head accordingly.
Just go to the next one, buddy.
Okay. Well, usually we demonstrate moving the box. If you guys stop by Hardware Hacking Village or Q&A or something, we'll try to demonstrate that there. But I can't really see the screen, so sorry about that. I'm not kidding.
Well, no, we got like 5 minutes yet. How's this work?
All right.
All right, so I'm Josh. I'm Grungy, whatever you want to call me. It's cool. But I'm going to talk to you about how we use the Wii Fit board in our whole system here. And we were kind of just kicking around one day. We got the tracking and everything, and you can move the mouse around like you just saw. And that's pretty nifty and everything, but you can't really do anything once you get to that spot on the screen, which kind of is the point of a mouse, is to actually interact with the computer. So to add that extra functionality into the whole system, we're trying to think of ideas and everything. We asked our professor, and he had some cool ideas about this. And to do right-click, left-click, and all the normal Windows functions, we're like, all right, maybe you can't use your hands as well. Maybe you have multiple sclerosis or something like that. But you should be able to. It doesn't take too much to be able to shift your weight around, and that it takes a lot to get yourself not to have the accuracy to do that. That's most people, I think. So what we did was we realized that the Wii Fit board has pressure sensors in each of its feet, so you can tell where a person's leaning, and Nintendo uses that in like their yoga programs and their aerobics and stuff like that to do that. So basically the features we added was right-click, left-click, scrolling, and actually even opening the gesture program in our whole thing. To do right-click, left-click, and scrolling, that's just you use basically a Windows function called send input, and you can just look that up in MSDNA or check out our code when we release it. And to do the actual gesture program, I thought that was a really cool part about this was you have to install what's called a Windows hook, and what that does is it sits in like the message queue in Windows and watches all the messages go by that are going to all the windows, and it says, oh, I'm looking for this, that's not what I want, until it finds the one it's looking for, and then says, oh, I'm actually going to process this message. And that's what tells the gesture program to sort of open up and let the user, say, do a circle and open up Microsoft Word and the speech recognition software, whatever they want to open, so you don't have to go through all the menu-driven stuff. And I think that added a whole new level of functionality. Also, bonus points if you know what that error code means in Microsoft compiler. I get that one a lot. So, do you want to do?
Yeah, let's do this.
All right, so we're gonna try attempt to do the last demo because we'll see how good Rob is. Here you go. Throw in a presentation.
All right. So originally we were gonna do Duck Hunt and just try to demonstrate shooting the old NES game and like shooting the duck, moving your head and clicking. But I just realized that I can't see the screen, so it's not gonna be too effective.
You can stop by later if you want to try.
But so I just came up with this idea, or I think I heard a friend of mine say at one time, how about use Paint? So we'll try to use Paint to just show that we're clicking and moving around. Watch out, Josh. Yeah. Hitting the wrong now. All right, it's calibrating now. Let's see if we can do this.
This is without hands. Yeah.
Am I on it? All right, tell me when I'm on the screen.
You're on screen. Oh, you made a little. Ah, yeah.
All right, finish it up. All right, now Sarah. We're about to be done. What?
Are we good?
Yeah, that would have made sense.
All right.
Yeah. Sort of just want to thank everybody that was made like using the Wiimotes possible, and Wii use, and all the independent hackers out there. Thanks.
All right, we should be. Keep an eye on this website. We should be posting our source and all that stuff in the next couple months. Just keep an eye out, and thank you all for coming. We thank you all.